Welcome to our IGCSE chemistry series. In today's episode, we'll explore the fascinating topic of states of matter, including their properties, interconversions, and practical applications. Let's start with the three states of matter: solids, liquids, and gases. Each state has distinct characteristics based on the arrangement, movement, and energy of its particles. In solids, particles are tightly packed in a fixed arrangement. They vibrate in place but don't move freely, resulting in a definite shape and volume. In liquids, particles are still close together but can move past each other, giving them a definite volume but allowing them to take the shape of their container. Gases have particles that are far apart and move quickly. They have neither a fixed shape nor volume, expanding to fill their container completely. Now, let's discuss how these states interconvert. The main processes are melting, freezing, boiling, condensation, and sublimation. Melting occurs when a solid turns into a liquid, usually by adding heat. This increases the energy of the particles, allowing them to break free from their fixed positions. Boiling happens when a liquid changes into a gas as it absorbs heat. Conversely, condensation occurs when a gas cools down and turns back into a liquid. Freezing is the process where a liquid turns into a solid. This occurs because the molecules in liquid lose energy, move more slowly, and become tightly packed, forming a solid structure. Sublimation is when a solid transitions directly into a gas, like dry ice turning into carbon dioxide gas. Boiling and evaporation are both processes where a liquid turns into a gas, but they differ in key ways. Boiling occurs at a specific temperature, boiling point, and happens throughout the liquid, with bubbles forming as it rapidly changes to gas. In contrast, evaporation takes place at any temperature below the boiling point and only at the surface of the liquid. Boiling requires continuous heat, while evaporation occurs naturally and more slowly without the need for added heat. Now let's talk about diffusion, the process by which particles move from an area of high concentration to an area of low concentration due to their random movement. When a bottle of perfume is opened in a room, the gas molecules from the perfume spread throughout the room due to diffusion. Eventually, the scent can be detected all around the room as the gas particles have moved from the area of high concentration, near the bottle, to areas of lower concentration. Next, let's define some essential terms related to solutions. A solution is a homogeneous mixture of two substances, a solute and a solvent. The solute is the substance that dissolves, like sugar or salt, and the solvent is the substance that does the dissolving, such as water. Together, they form a solution. If you continue adding solute to a solvent, there will come a point where no more can dissolve. This is called a saturated solution. Now let's move on to the concept of solubility. Solubility refers to how much solute can dissolve in a solvent at a specific temperature. We measure solubility in grams of solute per 100 grams of solvent. The solubility curve shows how the solubility of a substance increases with temperature. Understanding these curves is essential when working with different substances, as they help predict how much of a substance can dissolve at a given temperature. I hope this video has helped clarify these important concepts. Thank you for watching, and if you found this lesson useful, please consider subscribing to the channel for more educational content.